mobile wallet in a couple of weeks with some new ideas around usability, and that includes using MetaTransaction. So basically, our users never pay gas, so we pay gas for them all the time, and we have a relay system. So all the transactions are converted in MetaTransaction that are then relayed and published by our relayer. And at the moment, we just have one relayer controlled by us, but of course, we're also interested in all the ideas of having a network of relayers that are competing for users' meta transactions, things like this. And long term, well, middle term, midterm, we're also looking at sort of scaling, so doing mass validation of these meta transactions using IDs such as ZK snarks, things like this. And we're also looking at any sort of privacy solution that can hide the meta transaction in particular, but we're also looking at privacy for other aspects of our wallet. So yeah, that's
interesting. So in terms of privacy, just picking into that, where do you see the obfuscation happening in terms of user intent?
So one thing we're looking at, really, I mean, that's really seems pretty much like yesterday. So that's something that we're exploring, is the question of, so we don't want people to be able to see how much a user has on their wallet. And so we exploring the idea of having, there is sort of a funder wallet that the user may have with all their funds, and it's but it's not the wallet that they use to say interact with dApps. And then there is the Argent wallet, which they indeed use to interact with dApps. And then the connection between the two, that's where we're looking at things like ZK snark based mixing and other ideas to basically obfuscate. Really, what matters is to obfuscate the source of all the funds of the user, but not necessarily any single individual transaction they do. They use, say, CryptoKitty or something like that. But we're still very much thinking about these ideas. I mean, we are exploring the space, looking at what would make sense given our architecture.
Interesting. Yeah, I think it would be nice for actually Ali to kind of give input on this, since he's been working on anonymous transactions. I think you did you meet Ali at the Status Hackathon?
I don't think so, no.
Okay, too bad.
Yeah, but I think I had met him before. If we're talking about the same Ali.
Essentially, he's been like his idea was within the Relay network, right? Okay. Hi, I think that's from your team, Yo. I think his idea was basically to somehow, I don't know, like, I think on the Relay network, when you're actually signing the intent, it's just you obfuscate it through, like, I don't know, I guess potentially, I mean, first of all, you can obfuscate the timing of the message by delaying the transaction for a random amount of time. You have that. You have potentially batch transactions, kind of like ring signature stuff. I don't know, but yeah, I think it makes sense. Like, the interesting thing about Relay networks is that they don't need to secure state. They're like on a P2P level, like Relay networks, they don't need to be that P2P resistant or censorship resilient to a certain limit, because they don't secure state, right? And the interesting thing is that you can maybe spin a network up and get enough activity for it, and it can just be this kind of anonymous kind of entrance. Like, so it can be, so if it's the right blockchain, like this Relay network, it can be compatible with many different chains. It can just actually produce anonymous transactions for various chains, not only Ethereum. That's the interesting thing about, like, this Relay network. You can really just send information, it will execute as long as it can do so. Yeah. So any comments? Otherwise, we might just go on to the next point here. Cool. Yes, Sina?
Yeah, no, just wanted to ask like whether you guys at Ardent have had a look at like Mixeth and other current mixers that have been proposed.
Yeah, so I'm currently looking at that's one of the projects by Barry Whitehat. Has I think it's Miximus, but I'm literally just starting to look at this since yesterday. Yeah, I think, and there is also the what's it called, baby Zoe, baby Zcash on Ethereum, which seems to have very similar ideas, although it's a little bit older, so it maybe is implemented, I think, for pre-Byzantium. But yeah, and then there's some other, I just found out that some Ring CT tokens, I just literally found this out this morning, so I'm going to look at this as well. But it seems like there started to be plenty of interesting things done with ZK snarks, and it's a bit hard to keep up with all the new projects.
Yeah, that's true. Yeah.
My bad. So I think I skipped ahead here. Like last time we had like about 25 people in the call, and we kind of really didn't do much introductions. But I think a nice idea here is that since we're a much smaller group, we can actually do introductions this call. I think that'd be a wise decision here, maybe. So let's kick it off with you, Peter. Just something real quick, just to make it kind of make it more intimate, I guess.
It's okay. I'm Piotr. I co-dev at Ethereum Alarm Clock and other related stuff. Yeah, currently the clock is using some sort of relayers, not necessarily meta transaction relayers, but the idea is very, very close. Now we expanding a little bit and working on a meta TX is just like one of the ideas how we could use the relayers, and yeah, just moving forward. So main focus is scheduling, scheduling to the future and conditional execution in the future. So that's where we actually mostly interested. Also privacy preserving things as well, because that's like really a good use case for the relayers network. So now playing with this kind of ideas as well. And just coming back to Sina question, I know all of these mixer solutions, they actually suck now because of the lack of the account abstraction, where the peer-to-peer relayers can kind of replace that. Still not perfect, but yeah. So at the moment, I do design a peer-to-peer network for the relayers and implementing based on the peer-to-peer, and I picked at the of EIP draft. It's somewhat similar. I mean, sure, we discussed that at DEF CON, somewhat similar, but we want to minimize the on-chain footprint. So most of the communication will happen peer-to-peer between the nodes only. So that's the main idea. I can explain that later on, but let's go with the introduction.
Sina?
Yeah. Hi, I'm Sina. I've been working on a couple of side projects. One for decentralized relay networks, as well as an oracle for EVM events, which has a really similar architecture to Yoav's recent EIP, and I'm looking forward to discussing that. And I'm now helping Tenzorum with some research on the relay network and the peer-to-peer network. Yeah, and generally everything about meta transactions.
Yo, what's up, Chris? You just popped up in the chat. Yeah, Olivia, what about you? We already kind of presented kind of what you're working on, but yeah, some iteration would be nice.
Sure. So I'm basically in charge. Well, one of the people working on Solidity, but there are just the two of us in the team in Argent. So we do use meta transaction pretty much everywhere. So we have our own relayer. One thing I didn't mention is that we have currently a proof of concept of a sort of fork of MetaMask, which uses So instead of having like a EOA account in MetaMask, you have actually connect to the Argent wallet in MetaMask, and you can interact with the dApp by issuing meta transaction as well. So that's one of the projects that I've been actually working on in the last months. Yeah, I mean, generally we at Argent, I think our focus is very much on usability, and there is one aspect of this means all the questions around seed phrase and making sure the user doesn't have to think about seed phrase. So we have some sort of social recovery that we call Guardian. And then another aspect is indeed all these meta transaction related things and making sure that the user don't need to think about gas and gas price. So these are kind of two very important themes for us. And then going forward, I think privacy is going to be a third a very important theme, at least that I will be involved with.
Gustav?
Yeah, hello. I've been working on a project called Trust Lines for a couple of years. That's a payment network. And we've also, behind the scenes, been doing a lot of meta transactions. And then most lately at the Status Hackathon, I teamed up with MetaCartel, who's also in this call, from U2 and from Volcatech. And we have sort of been working a bit with Alex and some of the other people from Universal Login to extend that with an invite link functionality. So that's also what exactly mostly brings me here right now, to basically see what's going on in the space.
Yoav, would you like to introduce yourself? Hey man, your audio is not working. We can come back to you, and then if you make some noise, we'll let you know once. That might be a better solution. I can't hear you. Mark, would you like to go in the meantime? Just make some noise, Yoav.
Yeah, cool. So I'm Mark from Tenzorum, where we basically had the approach of is bringing forward a better UX experience for users and developers in the Web3 space. So we created an SDK, much like Universal Logins, that resolves an address to an ENS name, and that addresses multi-sig that allows you to implement meta transactions. And we've kind of implemented that and tried having people use it at hackathons, and then we kind of stumble upon this rich layer 2 community that is implementing all kind of things around decentralized layers and anonymous transactions. And within our proposal is that we build a decentralized network. So it's awesome that we see a lot of people are kind of far ahead of us in terms of like ideas and implementation. Good for us to all standardize and work together to build out these like layer 2 solutions that can really benefit this space. But we see a lot of the applications on top of Web3. I played around with Argent's application and ETH 2.2.io with their links are doing really cool stuff. I think it can open up a lot of interactions.
Awesome. Just to ruin the fun here for everyone's introductions, let's keep it kind of quick and zappy from now on. Let's just like, hey, what are you working on? Where you at? And what's your interest so far? And what have you been kind of involved in the cartel? It'll be great because we would love to do introductions, but we have so much time in the day. We kind of want to go through George's presentation. Ali is actually going to come on board actually in 10 minutes to present his anonymous meta transactions, maybe after Yoav's presentation on his design on his EIP proposal. But let's continue it on and go to Kay first.
Yeah, it's clear.
Okay.
Yes, we can hear you. Sorry.
Can you hear me now?
Yeah, we can hear you now. Sorry.
Yeah, I figured out the audio problem. So
I'm sorry for interrupting. Please go ahead. Sorry.
Right. So I'm Yoav from Tabuki, and there are also a few colleagues of mine on the call here.
And we're a security company working on something completely unrelated to meta transactions. But since we needed a solution, we needed a working solution for meta transactions, so we developed the gas stations network, and that's the context of this call. Now, some of you have already seen it. I explained it. I explained it in this ad hoc session we did at DevCon. But so on this call, I can elaborate on it a bit. And last night, I also sent an EIP draft that pretty much explains how the system works. So we can discuss that, and I would love to get some feedback.
Cool. I'm sorry, Kate. Sorry. You're up next.
So as you have said, there are a few people here from Kabuki. So I'm Xu. I'm in the product team in Kabuki.
Mikhail?
Hi guys, I'm Mikhail. I'm from MetaCartel, and I'm focused on onboarding. I had some problem with audio, right? So, hi again, I'm Mikhail, I'm from Rolkotech, and I'm focused on onboarding. And as Gustav has said, we have collaborated at Status Hackathon and introduced the invite link functionality to Universal Logins SDK. And right now we are working on adding it to the SDK.
Hey, so I'm Pro. I'm working with OpenST or OST, Open Simple Token, and we are building a framework for the companies to build the token economy and onboard the users into their tokenized economy. And recently we have implemented the IP 1077 into our solutions, and we are very eager to learn about your findings about the meta transactions.
Cool. George, want
to? Yeah, hey, so I'm George. I'm part of LimeChain. We've been working on meta transactions for quite some time. We had an implementation of the meta transactions plus a relayer. We started working on relayer networks. Well, recently we've been actually contributing to many projects with what we have done, and we have paused the progress on what we've done. And today I'll be showing you my latest proof of concept, which is batch transactions, that is going to be very interesting and needed when you want to have an atomic ERC20 transactions. And yeah.
Mokhtar, would you like to introduce yourself? Man from Paris.
So yes, so I'm Mokhtar Bashar. Hi everyone. I work at Consensus since a year and a half. I started a project called Fuel about meta transaction as a service. So you can check my Fuel Web3 provider to integrate meta transactions directly in your current dApps. Just one line of code to change. So yes.
Awesome. Chris, I'm from Amigo ID. If you're there.
Hey. I'm currently still working with Gustav on trust lines and looking more into the end user facing situations. Probably going to change to work on a wallet also. And I'm working a little bit with Mikhail too on, let's say, a small demo for invite links. And I'm mainly here to stay in the loop on this topic. Thanks.
D-Raw, love a quick intro. I love these really ambiguous usernames. It's just like they make you question. It really tests your limit on like how to pronounce it stuff. But yeah. Okay. We can't. Sorry, man. We can't hear you. I think it's your team, Yoav, right?
Hello? Yeah.
Yeah, it's your team. It looks like
Yes, I'm now connected. I'm connected twice now. I
Cool.
just I switched to something that can work with a headset. So hopefully you can hear me better now.
Awesome. So Tom, I think you're the last one to kind of intro. Dave can't intro because he's sleeping. No, well, it's quite late over there. So
yeah, it's different time zones everywhere. Can you hear me?
Yeah, we can hear you.
Okay, great. So hi, I'm Tom from Portis. We offer an in-browser Web3 provider. We're also very much looking into layer 2 solutions because a lot of the apps need to be able to move fast, so to speak, with their transactions. And we're also very much looking into meta transactions. And we're really concerned about the whole concept of how you prevent abuse. If you're doing the relay, that's something which we find very interesting. So we'd love to hear your thoughts on that.
Yeah, I will introduce Dave since he can't introduce himself. He's kind of part of the MetaCartel. He's working on his own kind of agency, community agency for the studio. We'll see him around. So I think we might go on to the next point here with George's work on batch meta transactions. Do you think he can kind of talk about it in maybe 5 minutes, 5, 6, 8 minutes, and then have some Q&A? Then we can have the second half of this call just focused on maybe Yoav's work on his relay network design.
Yeah, well, however many you give me, this much I'm going to use. So stop me when you feel like.
Beautiful.
So I'll start. I'll try sharing my screen.
Sure, let's do it.
Cool. So yeah, tell me when you're seeing my screen.
Cool.
Awesome. So I'll start with the concept. So the concept is much like we're using the identity proxy to relay a single transaction. I have actually done something very simple, but I haven't thought about it until Ivo from ADEX actually suggested this to me, and I changed the bytes and signatures from a single bytes and single signature field to an array of such things, which basically allows you in a single transaction to call multiple contracts at once, or a single contract multiple times. And I feel that everyone can come up with a different way that this can be useful for them. But for me, something that everyone has experienced as a pain is actually interacting with ERC20 outside of just a genuine transfer. So basically the workflow of having doing first an approved transaction, then once the approved transaction is good, then you call a service smart contract that internally uses transfer from the same contract. And like, first of all, it's very, very bad for UX because you have two transactions. In case of MetaMask, you have 2 times MetaMask popping up or whatever is there. It's slow. You can end up with interruption midway of this flow. So I will show you a little bit of code, but before that, I will just run my unit tests, and then I will show you what my unit tests do, because it's going to be very, very simple. So first of all, let me prove it that this works. And I'm running this against Garage. So I have written just 2 tests. One is saying executing successfully a batch transaction. The second one is should fail and revert everything on failing second transaction. So let me show you first some contracts. And by the way, Peter, whenever you feel like stopping me, just stop me. But I would love at least for me to show you the proxy. This is something that for most of you is you're very familiar with. It's basically the identity contract. I have stripped it out of the relay reward stuff. I have left it only with the things that are relevant to the batch transactions, but you can basically, it's going to be very easy for you here to just add relay rewards and gas prices and whatever it is there that you feel you should be adding here to the execute method. So I have made the target contracts being an array of addresses, value is array of units, data is array of bytes, and signatures is again array of bytes. By the way, this is only going to work with experimental ABIF caller version 2, because otherwise you cannot have a bytes array. And here is the general modifier that we all know about. It basically says, if the correct person has signed a transaction only, then I will going to go ahead and execute these transactions. And once this is done, once this modifier passes, basically we loop through all the targets on the order that has been supplied by the users, and then we call them with the correct value and the correct params. And yeah, for the tests that I have been using, I have created a very simple contract that is basically has a buy function, and you put some money into this contract through the buy function. And the next person that wants to buy this good, whatever it is, needs to put at least one token more than the current person. See here, the required, it says the token that you're passing needs to be more than the current price. And once you have this, once you pass more tokens than the price, basically the price becomes the tokens that you have passed. So everyone needs to get more and more tokens into this. So you can think of this like a FOMO 3D game or whatever it is. And I have created just a simple token out of OpenZeppelin. It's mintable token that I have just added details to. And yeah, lastly, I'll show you the code that does whatever it does. And I'm going to run through it very quickly. And I'll post you later the repo so that you can go through it in your own pace. But going through it, I'm deploying all the contracts, including the proxy and the billboard contract that I just showed you, the service contract. And I'm minting my contract, my proxy some tokens, but basically this can be just a normal transfer. It doesn't need to be minting here. And first, I'm preparing all the data that is there for the all the data that is there for the approved transaction, which is, by the way, I'm using ethers. So in ethers, you just go to contract functions and code with the correct parameters. Then I'm hashing this, signing this. So basically generating all the needed data for approved. Then I'm generating all the needed data for buy. And my two tests are basically very similar. First time I called the execute method that I showed you with the params that I just generated, and everything goes through. Everything goes through. The balances are correct. The service contract already has the correct amount of tokens. So this by itself is great UX improvement, because we basically in a single transaction did the two approve and transfer transactions. And another thing that is very, very cool is here again, I'm going to use the same data that I generated in the before, but this time this should fail, because as I showed you in the billboard contract, basically you need always to be sending more data, more tokens than you have previously sent. And in this case, I haven't changed that. So yeah, in this case, all of this is going to revert. And what I'm checking here, so that I'm sure of, is that the allowance is not the allowance towards the contract is actually have not changed. And this means that when our transfer from transaction has reverted, our approved transaction has reverted too. And yeah, this was the fastest way that I can explain this.
Oh, good. That's doing. Yeah, it's actually quite a lot. Yeah. I think Mokta had a question here.
Yeah, that's really interesting. I love it. This idea to execute simultaneously in the same transaction to different call. But my question is, do you think you can easily implement that with two different smart contract address? Because
yes, this is already implemented.
Okay, because like what I've seen, if I'm correct, it was two calls for two different functions in the same smart contract, right?
But let me show it to you again. So you see my screen, right?
Yes.
So here is the proxy. You see here the execute. The first parameter is address array. So basically, you can put the one contract here and then the other stuff, another contract here for the second.
Oh, okay. I didn't see the address array. I see.
Yeah, everything here is array.
Okay. Yeah.
Yep.
That's really cool. That's really interesting. Nice.
Cool.
Good job.
Any more questions, guys?
Yeah.
I would love, by the way, if we have 1 more minute, Peter, for anyone that can tell me how would they use something like this outside of QRC20. What is a hardship that they have in their dApp that they need to use multiple transactions chained one after the other? And
that sounds like a forum thread on our new discourse.
With that stuff, you can do arbitrage and decentralized exchange on the same block. That's really cool.
Interesting, actually.
Cool. I'll post, so back to you, Peter. In the meantime, I'll post the GitHub repo into the chat and in the MetaCartel chat too.
Beautiful. Ali just popped in the chat. And I think he might, I think we're going to go first of Yoav's designs, relay network designs first, and maybe Ali can kind of present your transactions after his long discussion. I expect this to potentially be squeezed in at the end if possible. Sound good?
Yeah, that's fine.
Awesome. Yoav, take the stage, I guess. Yeah. You can potentially screen share, if you will, and you can kind of poke and look over things.
Actually, that would be harder since so I don't have the right setup for that right now. It's it's on a different machine. So, but I think you all have access to the EIP, which describes it, and I can point out things from there.
Yeah, I can screen share actually myself, and you can go over potentially. I just posted the EIP into the chat. Yeah.
Okay. So anyway, what we built is we needed a way to get collect calls or reverse charge calls on into smart contracts, so that you can make a gasless transaction. And the way we chose to implement it is through a decentralized zero trust network of relayers, which we call gas stations. So I'll talk a bit about the implementation, and then we can dive into as many details as you like. So the basic design is that we have a singleton contract, a single contract on the entire blockchain, which we call the relay hub. And all the relay hosts are going to register in this contract and advertise a way to reach them in the form of a URL for web or for Whisper or whichever protocol they choose to protocols they choose to expose. And their address and the transaction fee they're going to charge, which is a multiplier on the gas cost of the transaction. So they're going to advertise their presence in a central contract that's going to emit events, which you can then look at. And on the other side of it, each contract needs to implement an interface called relay recipient. And in this interface, they define which relay hub they trust. So they have the address of a relay hub. They accept general transactions from there. And relay hub also does the economic part, moving ether deposited by smart contracts to the relays. And what we really focused on is the economic model to create the right incentive structure, so that each entity can do its job properly. So let's see how should we. So I think since I already explained most of it before, maybe we can dive into questions and I'll take it from there. So what part would you like me to focus on?
I think interesting point is that like how this design actually doesn't need to solve the collision aspect of actually knowing how to distribute the meta transaction.
Okay. Yes. So the reason there's no collision is that the user, the app that's going to send a transaction is the one selecting which relay to use. So all the relays advertise their presence, their price, and you can monitor the reputation on chain. You can see actual transactions that they sent through the relay hub. And using this, you can make a decision on the sender level, decide which relay you would like to use. And once you choose a relay, you don't need to wait for anything to happen on chain in order to know that the transaction really happened. Because what the relay does is, after you send the transaction to the relay, so it's supposed to sign the transaction and put it on the chain, but it also returns the signed transaction to you. And this fixes the problem where otherwise you would need to trust the relay and wait until the transaction gets mined in order to know whether it did its job. So if you choose a bad relay, you have a very long delay until you can choose another one. So instead, the relay returns the signed transaction back to the sender. Now the sender can check the transaction, make sure it's okay, and also put a copy on it put a copy on it on the blockchain. Send it as well. There's no problem in sending the same transaction twice. Since it's identical, it will only happen once. So and by this you keep the relay honest, because if the relay doesn't put the transaction on chain, then it is stuck with a bad nonce. It cannot do the next transaction. Or if the relay is malicious and tries to and puts a different transaction with the same nonce, then it can actually be punished, because now you have two transactions on chain with the same two different transactions with the same nonce from the same relay. And if a relay does that, then it loses its stake. Each relay has to put a stake when it registers. And so if it's malicious and it's putting two different transactions with the same nonce, you have a call in a relay hub where you can prove it. You can show two transactions, one of them reverted, and put two different transactions. Relay hub will verify it, and then it will confiscate the stake of that relay and split it between the sender and the relay and the other relay who helped showing the attack. So with this design, we don't need to deal with collisions, because you can talk to one relay. The relay is incentivized to do its job. And if it ignores you and doesn't, if it returns a transaction, you know it's going to be okay because of what I just explained. If it ignores you and doesn't give you a transaction, you know about it immediately because it happens in the same HTTP request. You get it in it. So if you don't get a reply in like 2 or 3 seconds, you just drop the connection and talk to another relay, which means that you can go through the relays rather quickly and make sure your transaction gets there. You don't need to send it to multiple relays at once.
It's almost like a market mechanism. So it's almost the DApp, right, essentially is allowed to actually choose the relay itself with the different conditions and prices set by the relay itself, right? The
DApp is by saying DApp, you mean the contract or the app running on the user's device?
Yeah, I guess the app running on the user's device.
Yeah, it's. You could implement it. You could implement it differently by. On the app basis. It can be. Since the app decides which node to connect, which relay to connect.
You went mute there. Sorry. Sorry, we can't hear you, Yov.
Hello?
Yeah, we can hear you now.
Okay, good. So the app can decide which node to connect to, or it can, or you can use your backend. You can make the decision in a backend of your app, in a centralized backend that tells app which relay to use. It doesn't matter, but in the end, the app talks to a single URL, and you can have as many of these as you like, since each relay can publish its URLs.
On what I guess the relay itself would obviously, I think it realistically be chosen a default chosen node or relay by the backend itself or the app itself, right, for the user. How would this, like, as from what I hear, as opposed to having a very homogeneous kind of network of various nodes that do the same thing, and get equal token distributions, hence you have the collision problem. How do you split equally across the whole network? I have act as a homogeneous kind of network itself. This design is actually almost allowing open protocol for market to occur in terms of in terms of like relay pricing. Is that correct?
Yes. Yeah, that's correct. So each relay can set the price. So the market determines the price for transactions, and the relay is also a relay can also decide whether it wants to serve you or not, since each entity in the system is autonomous and they're not coordinated. So when a sender decides to talk to a certain relay, it means that it agrees to this relay's price. It's going to state that so the sender is going to state it in the signed transaction.
Yep.
So and authorizing the relay to charge the DAP and to charge the DAP this amount. The DAP also authorizes it through a function called MayRelay that the relay needs to call, and the relay uses a view function before making the actual transaction, checking whether the DAP is whether the destination contract recipient is going to accept the charges. It tells the contract about who the sender is, what the transaction is, what the cost is, and everything that it needs to know in order to take a decision. So if for whatever reason the relay doesn't want to serve you, it just returns an HTTP error telling you to go elsewhere. So you can just pick a different relay.
So just a small question. How do you protect against replay attacks for the user's transactions?
So
can they be replayed?
No, they can't be replayed. So the Relay Hub, which I'm seeing, all the transactions go through Relay Hub. Since relays and contracts all communicate through the Relay Hub singleton, and Relay Hub holds a map of nonces for every sender. So the first time you send something through the relay network, you get your nonce starts with 0, and then it increases. The counter increases each time, and the transaction must work with this. So when you create the transaction, you use a view function to get the nonce, and the transaction has to include that nonce. So every transaction can happen exactly once. And you can scroll down if you have the EAP that I published yesterday. You can scroll down to the rationale part, and there I have a list of attacks and mitigations. So replays, the way we prevent replay is I elaborated on it in the EAP, and so yeah, we prevented that.
So basically, there are two kinds of nonces: nonces for relayers and nonces for senders. Did I get that right?
Yes, you have there are the normal Ethereum nonces for the transaction. That's for the transaction, but there's also a per sender relay. Since the sender never sends Ethereum transactions, it doesn't have any Ether. You need to implement the nonces separately.
Got it.
So I have a question about the rewards for the relaying. So if I'm not getting this, I mean, if I get this right, you talk about the Ether rewards for the relaying, right? Because you said that there is like a percentage or a fee, which is like advertised via the Relay Hub contract.
Yes. So
okay.
So I'll explain a bit.
I think. I mean, this is interesting. And before you joined, I discussed with Peter that I end up with quite similar approach, but I try to eliminate the Relay Hub as much as possible. So some of these interactions and bidding and offer, like interactions between the sender of the meta transaction and the relayers, are actually happening on peer-to-peer network. So what we have now is that if you are interested in sending the meta transaction, you just join the peer-to-peer network and you advertise your like willingness to make some sort of transaction to happen, and then you gather the bids from the relayers that are currently available, right? So that solves some sort of availability issues. If you have like Relay Hub and then those relayers are not online currently and so on. And then you could choose whatever algorithm to pick which relayer is supposed to relay. Obviously the easiest one is like the cheapest price and the fastest response. So time and price. And then there is like a game on negotiation, because you can essentially, if someone gets you an offer, you can then authorize by signing the transaction for him for the address that he used. You can also check whether there is like any staking contract that you need to check if this is like a trusted relayer. And then obviously you might get like into two paths, either like asynchronous protocol, so you wait until someone do that, or you put some like partial asynchrony, which is like essentially a timeout conditions for this whole thing, which means like if someone sends you an offer, you sign the message. The message also may contain some time lock, that is verifiable on the smart contract. Let's say after 5 seconds, transaction hash response to you, which is like a proof of, including transaction, then you follow with another relayer. So it's like a quite simple protocol that you can build and then get rid of, I think, the Relay Hub and just probably enable a bit more reliable network by doing this.
Mm-hmm.
And the additional thing with the bidding process is that you can essentially put the asset that you want to pay with, and then relayer came up like live conversion, how much actually of this asset is requested by him to relay.
And what protocol does the user application need to use in order to interact with this peer-to-peer network, in order to publish something and get?
Yes, well, this can happen. This can be done. I mean, what I build is on top of lib peer-to-peer, so you can actually talk within your browser, so JavaScript. So it's like a thin client to the lib peer-to-peer. Sure, you can use some centralized like an API just to talk through, if that makes sense as well.
Mm-hmm. So one of my design goals here, I wanted it to on one hand not to require any peer-to-peer protocols or interacting directly with the blockchain, because I wanted to work on mobile applications, working in restrictive networks. I had that experience in the past quite a lot, so I know that communication can be quite limited. But on the other hand, I didn't want to make it centralized. So if I created a design that required required a central, like an HTTP server that you can communicate with in order to do it. Then now the system becomes centralized around the server, and even if you're going to have like 5 of those, it's not good enough. So by having relays advertise their URLs and let the user choose, it means that you can have you have at least as many different servers as the number of relays, but still you only need HTTP in order to interact with them. So with that, so it kept us decentralized without requiring a peer-to-peer protocol.
Yes, sure. I mean, just like what I'm saying, like you always gonna make some trade-offs in some of the directions. So absolutely fine.
Mm-hmm. Yeah. So exactly. That's sorry. Go on.
No, I had another question about how do you know that if the relayer do you verify the transaction signature on chain?
I'm sorry.
If I want to use a certain relayer and I send the message, send the signature to him, he gives me back the signed transaction, and then I broadcast it to the network. Is that how it currently works?
That's part of the story. It's you send a transaction, you choose a relay, you send a transaction to it, and the relay does 2 things. I mean, after the relay verifies it with the contract, decides that it wants to serve you. This all happens during the HTTP call, and then at that point, it does 2 things. I'm sorry?
When you say transaction, you mean signed message, right? Because if I send a transaction, then the from okay, yeah, okay. So
yes,
yeah,
so you send a signed message. You send a signed message to the relay, asking it to relay to a certain contract, to a certain recipient through Relay Hub. After it verifies that it wants to do it, this happens immediately, and then it does 2 things. After it generates an Ethereum transaction that can pay for the gas and deliver the message, it does 2 things. One is it puts this transaction on chain, which you're only going to see in a few blocks after it gets mined. But the other thing it does is it returns the message to you. And this happens immediately as the response to your HTTP request. So now you have a copy of the message. You don't know for sure whether the relay is honest. If the relay is honest, then it also put it on the chain. But if not, now you have a raw transaction. You have a signed raw transaction signed by this relay that you can put on the blockchain. You can go to some other node or to some service like Infura and just put it on chain, because it's okay to put a transaction twice. It's identical. It will only happen once. So this way you know immediately. You don't need to wait for it to get mined.
Yeah. No. Yeah, you're right. But there could be a few issues. For one, the relayer's account may not have any balance, so he may give you an invalid transaction. So
that's part of what you verify. So in the EIP, you can see a list of things that the sender needs to verify. One of them, when you get a transaction, you also verify the balance. You verify certain things about the relay and about the destination, so you know whether the transaction is going to go through.
Yeah, no, because what I'm saying is that a signed message, the transaction that he returns to you does not have to be exactly the same as the one that he broadcasted, because if a relayer is handling multiple requests, then it's very natural that the nonce will be increasing really fast, and he may give you something else, and he may have actually done the right transaction or the other way around.
So it's a relay can only serve one transaction at a time, but it's for a very short time, so it's okay. And if the relay, and eventually the relay needs to give you a transaction that will work on the blockchain, and it is incentivized to do so, because actually if it doesn't do so, if it gives you a transaction that's going to fail due to having a bad nonce, if it generated another transaction with the same nonce, then this is provable, because now you can look at the blockchain. You can say, you're going to put the transaction it returned to you. You put it on the blockchain and it gets reverted because there was another transaction from the same relay with the same nonce. In this case, you can grab the transaction that did go through from the blockchain. So now you already have in your hands two different transactions signed by the same key with the same nonce. With this, you can call the penalize function in Relay Hub, and this function is going to verify these conditions, seeing that the relay generated two different transactions of the same nonce. It's going to confiscate the ether that was deposited by the relay when it registered, and give it to you and to a relay that helped you prove it, that helped you put it on chain. So you know that the relay is incentivized to always keep track and give you the next correct nonce.
Yeah. And the rewards come from the dApps that are using it. Where are the rewards coming from?
Yes, so when a dApp wants to start using the relay network, it needs to first implement the interface, the relay recipient interface, and second, it needs to deposit a small amount into Relay Hub, and always keep enough ether there to pay for the next few transactions. It can be paid by the dApp itself or by an external address on behalf of the dApp. It doesn't matter, but there needs to be a balance, and the reward comes from there. So Relay Hub always has enough ether on the balance of each dApp, and when it's going to ask the dApp whether it can. It's going to add enough. It's going to pay for the transaction. The relay first asks Relay Hub to verify that it's going to get paid, that the recipient is willing to pay to accept the charges, and then when it makes the transaction, as part of the transaction, it gets compensated for the gas price multiplied by the fee agreed between the user and the relay. So the dApp can know how much it's going to pay, and it pays for the transaction during the transaction.
Okay. Yeah. No, that makes sense. Yeah, that makes sense.
Can you also maybe give a short intuition on how to prevent Sybil attacks in this case? I saw that in the EIP draft there were. This issue was also investigated, but is because how it seems to me is that the dApp should trust the users from before. It's kind of needs to know which addresses will be sending transactions and only reward those users. Otherwise, it can be overloaded with Sybil.
Of course, yes. So Sybil attacks are for anything that has collect calls cannot be entirely anonymous. You need to know about senders, because otherwise people are just going to rob you of whatever deposit you put. I mean, if the dApp puts any deposit, it's going to get robbed. and we suggested a few models that fit different types of dApps. And and when we release the code, it's going to include some examples of these. So one way to do it is, let's say, if the dApp only has known users, then it's easy. You just have a whitelist. You have a whitelist of senders. Another more common situation is that you have people registering to an application. Let's say you implement a game like CryptoKitties. So you have users registering in your website. So once a user is registered, you can create a balance for the user. And you can sponsor the user, or the user can actually pay for it. Let's say you keep it. It's a balance sheet. It's a balance sheet you keep in your dApp. It looks pretty much like the balance sheet you have in an ERC20 contract. You basically allocate gas tokens, your gas tokens, not unrelated to the gas station network. You have gas tokens for your users. And let's say a user goes to your website, pays using a credit card, pays $10 or whatever, and then you allocate this amount and you put it on chain on the balance sheet for that user. So now the user can send as many transactions as he wants, just as long as he has enough balance. And your main relay function is going to looks at the balance for the sender and sees whether the sender still has balance left. So now Sybil attacks are prevented because users can only spend what they already deposited in a different currency. So you can have that, or you can decide that you're going to throttle Sybil attacks. Let's say you decide to sponsor your users. You don't want them, you're going to make money elsewhere, and you use your own money to pay for users' gas. So the way you prevent Sybil attacks in this case is by making sure that people cannot create an infinite amount of Sybil addresses by using CAPTCHA. Or the easiest way to do this now is to require to sign in with a Google account or a Facebook account. It's really trivial to add to any application now. And then you can trust that Google already does a pretty good job at slowing you down if you try to create a very large number of accounts. So anyone can sign in with a Google account. They don't need to actually tell you what the Google account is. Google just tells you that it just gives you some unique identifier for the account, some long number. And you can use that and associate it in your app associate it with a sender address. So once the sender proves that he has a Google account, you allocate a certain amount of transactions that you are going to pay for that ID. So this way, Sybil attack requires opening a very large number of Google or Facebook accounts. It makes it less economic to attack you. Okay, and
thanks for explaining.
There was okay. I'm sorry.
Sorry.
So how you
mentioned that?
Sorry.
Sorry. Go ahead.
Thank you. So to protect, I'm not sure again, but to protect Sybil attack, you need to have a Google account. No, that's correct.
No. It's a per application decision. Every application that uses the relay network, every application needs to decide based on its own model, based on the business model, how it's going to handle Sybil attacks. It needs to know about senders, because senders otherwise you could have a sender with actually a relay. So I'm starting a relay with some advertising a high fee. And then I'm using my own relay, generate a lot of sender addresses, and I'm robbing dApps. So the dApp needs to decide whether it's going to trust a certain sender. So it needs to be some sort of whitelist. It can be based on the user paying with fiat or some other currency, or it can be controlled by your website.
So yeah, I get it. The idea is just to say to the business, you handle the replay attack by the way that you want, or the Sybil attack, right?
Another question I had is, so from what I gathered, the contracts should implement this interface, the recipient interface. This means that already deployed contracts cannot make use of this protocol. Is there a way to have a proxy contract that implements this recipient interface that itself uses this protocol, and on the other side calls an already deployed contract? Like, let's say there's a ERC20 token that some DApp has already deployed. Do you think that would be possible?
I'm sorry, I didn't quite understand. What do you mean? I mean, you mean how to add it to an existing contract?
Yes, exactly. Is it possible to use this protocol to an already deployed contract?
No. If it's already deployed, then it's not going to trust Relay Hub. It needs to know at least the address of Relay Hub, because one of the things we wanted to solve is knowing the real sender. So, I mean, if you get a transaction from the relay, then message sender is going to be the relay address, or the Relay Hub in this case, the Relay Hub. So Relay Hub appends information about the real sender to the transaction, to message data, and then you have a function that is part of Relay recipient to extract this information. So if you don't have this in your contract, why would you trust it? I mean, if you can, it will seem as if the sender is always Relay Hub. If it's an ERC20 contract, it means that now all the tokens belong to Relay Hub. That's not going to work. So you need to implement the Relay recipient interface in your contract, but it's really easy to do so. You only need to say that your contract is Relay recipient, and then to replace the message.sender everywhere with get sender. That's pretty much it.
Okay, thanks.
Okay, but it does mean that you need to redeploy.
Any other questions? Because we could potentially, we have a forum here, which I'm trying to desperately get people to use, which is a great way of actually just communicating asynchronously. Like, maybe you can post just your link there, and maybe if anyone has any questions, they can just probe you on that. It's fairly empty at the moment, but yeah, it might be a good way to actually just sync or any further discussions up. Potentially we're running pretty late here, but Ali, do you still want to present your designs, work during the Status Hackathon? No?
Yeah, I mean, I can go a quick 2-3 minutes, just the idea, and see what people think. No, I wouldn't go into the detail.
Yeah, sure. That's fine. Yeah.
Because I know it's already late, and I don't want to hang on people. So the idea was actually about somehow achieving anonymous tokens, or the idea was going with anonymous tokens. That was the goal. But the main thing on how it works is this: you have an ERC20 contract, which is a token, but instead of storing the addresses, it stores the hash of the addresses, and instead of transferring based on message sender, it transfers based on a signed message that's passed to a signed message or an array of signed messages. From which it recovers the addresses and then does the transfer. So how it works is basically when a user wants to send something to someone, the recipient's address is hashed. It's then a message is signed. It's broadcasted to a network, so very similar to how you've done. You have the EIP. There are relayers who listen for this broadcast, and then they look at the message. The message has a specified reward in it, and they execute the message. In this case, there is no staking mechanism or anything like that. It's a simple that. But one of the cool things about this is that what I do essentially is create a UTXO model on top of the token. So if you want to transfer, if you want to transfer 5 tokens and you have 10, you create two signed messages. One where the address, where the recipient's address is the hash of the recipient's address, and the other one where you create another account for yourself, and you transfer, you sign the message so that it does that. So recently, I've spoken to the MixETH people, the MixETH and the Mobius and Miximus. So they are all mixing solutions, and it turns out that it's closer to a mixing solution than to an anonymous token. So right now, you can already do that, and if you can do the mixing in a uniform manner with multiple people, then you can actually achieve. It would be pseudonymity, not quite anonymous, because there's still a single identifier, which is the address. But the idea is that every time you're moving addresses so fast, and they're all zero balance addresses. So even if someone knows an address, they know that you were using this address at some point in time, but they don't know what addresses you're using right now. And by the time when you make a transaction, you essentially reveal the address that you had before. But at that point, you've already made several other transaction outputs, and you've moved to another address. Does that make sense, or is it? That is very quiet. No, is it confusing or?
No, not really. It's just I had my concerns around this. It's just like, yeah, I don't know. I think it's a really interesting idea. It's much more like mixing. You're right? Like
Yeah. So the idea at the start was not to make it a mixing solution and not to use your knowledge proofs, because just a comparison of other solutions that are out there right now. Some of them use very cool cryptography, and some of them zero knowledge proofs. And the problem with zero knowledge proofs is still whoever does the initial trusted setup has to know. Well, you must trust them that they did it correctly, and they do not hold the secret key, so that they can make fake messages, like sign fake data or things like that. So there are trade-offs, but so one of the good things about this solution is that it's very it's cost-effective, because and it's actually deployable on the Ethereum network today. It provides you some anonymity, not complete, some pseudonymity. You can essentially even hide the balances with having multiple transaction outputs, because the whole idea is that since you can spend multiple outputs at once with multiple signatures, you don't have to use, like, you don't have one account. You have multiple zero ETH accounts, which can be transferred at any point in time. So the original thinking was that if the wallet provider wants to facilitate this kind of thing, then they can deposit the contract. They can deposit within the contract, which rewards the relayers, and if then anyone else can basically come in and register to the wallet provider. The wallet provider knows who you are, so they can prevent Sybil attacks and things like that, because you're essentially making transactions for free, or they are charging you. So that was the first model that came at the beginning.
Cool. Do you have a repo on this or any other links to this work?
I have one somewhere, but it's not documented at all. So
cool.
I'm in the process of documenting now, and hopefully by in a few days I have it documented properly, and
awesome.
it would make a lot more sense.
Just a quick question. Is there any limitation to the participants? So can I just deploy this and use it by myself, or is, like, for example, in Mixed ETH, you need like 6-7 participants to come together and start this process of mixing?
Yeah, so in this one right now, because as I said, it wasn't made to be a mixing solution, so no, you don't need anyone. You can use it alone, and because all you're doing is that you're as long as it doesn't care about the number of participants. It's as secure as you using it alone versus you using it in a million people, because it does leave a trail. So the problems with this solution right now is that it does leave a trail behind, so you can see from which addresses things moved, although they don't mean anything, because they don't have any ether, so that's like they're all useless accounts. But yes, so it's right now you can actually deploy it yourself, and what you have is that you have an hash you have a mapping of bytes 32 to uints, and if you just do uniform uints and the contract only allows the uint to be a specific number, then you've essentially hidden the balance of whatever. So yes, it does not require any other participants like Mixed does or anyone else does.
Cool. Looking forward to seeing the repo.
Awesome.
Cool. Yeah, I'm just lazy to write.
I think any other questions? Otherwise, this might just wrap up our call this week. I think there's going to be a next week. There's going to be a call around the 1077 standard, led by Marek again, and potentially just further kind of like, I guess, sharing progress on where we've been. The Tensorin team has been kind of collaborating with ETHWorks just to work out the standard, and we're looking to just share the progress, maybe bring more teams into the fold now. But yeah, like any other I mean, now it's kind of like an open, like everyone probably wants to get off the call now, but anything else anyone wants to mention? One thing I like to mention that we have a discourse forum now. Let's use it. I think it's better than anything else we have. Telegram and Discourse, it's like peanut butter and jelly. You know, it's a 1-2 punch of crypto communities nowadays. So notes will probably go up there as well as a video. You can find it on there. I'll be spamming in the chat. But anyone else want to jump in and just say something or announce something? Otherwise, there's plenty of opportunity to do so in the future. Cool. Thanks for coming. And see you guys some time else.
See you guys. Thanks.
Yeah. See you guys. Bye.
Bye bye. Have a good day.
Ciao.
Ciao.
Thanks, guys. See you.